Florida just released thousands of tiny assassins that crawl inside snakes and eat them alive. And before you think this is some horror movie plot, it's real. It's happening right now, and honestly, it might be one of the smartest things the Sunshine State has ever done. But here's the twist. These microscopic killers could also backfire spectacularly. So buckle up, because we're about to dive into the wildest biological warfare story you've heard all year. Let's get one thing straight. Florida has a snake problem. Not just any snake problem. We're talking about an invasion of Burmese pythons, so massive that it makes every other ecological disaster look like a minor inconvenience. Opossums? Down 98%. Bobcats? Nearly wiped out entirely. These pythons are so efficient at hunting that they've essentially turned one of America's most biodiverse ecosystems into their personal buffet. And the worst part? They have no natural predators in Florida. Until now. Enter the lungworm. Specifically, Rhabdias pseudosphaerocephala. Don't worry about pronouncing it. Just know that this tiny parasitic worm might be the python's worst nightmare. And yes, scientists are deliberately releasing thousands of them into the wild. On purpose. With government funding. Now before you start thinking this sounds like the setup for every ecological disaster movie ever made, let me explain why this actually makes sense. Sort of. The thing is, these aren't just any random parasites. They evolved specifically to target snakes in the python's native habitat in Southeast Asia. They're like a heat-seeking missile. Except instead of heat, they seek snake lungs. And instead of exploding, they just multiply until the snake can barely breathe. Here's how it works. And trust me, it's both fascinating and absolutely horrifying. The lungworm larvae hang out in the environment, just waiting. When a python slithers by, the larvae either get eaten directly or enter through the snake's skin. Yep, they can literally burrow through snakeskin. They make a beeline for the respiratory system, where they mature, reproduce, and basically throw a house party that never ends. The snake's lungs become so clogged with worms that it can't breathe properly, can't hunt effectively, and eventually, it dies a slow, miserable death. Sounds brutal, right? That's because it is. But here's where it gets interesting. In their native range in Asia, pythons have lived with these lungworms for millennia. They've developed some resistance. They can handle a moderate infection. It's like how humans can fight off the common cold. Annoying, but not usually fatal. But here's the kicker. The Burmese pythons in Florida, they've been living the good life. No lungworms, no parasites, no natural predators whatsoever. They're like trust fund kids who've never faced a real challenge. And now, suddenly, they're being introduced to something their immune systems have zero experience dealing with. The University of Florida researchers leading this project are basically betting that these pampered Florida pythons won't know what hit them, and early results suggest they might be right. Laboratory studies showed that when infected with lungworms, pythons experience significant respiratory distress. They become lethargic, their hunting success drops dramatically, and in severe cases, they die. Because releasing parasites into an ecosystem isn't exactly a decision you make lightly. Remember the cane toad? Australia thought introducing cane toads would control beetle populations in sugarcane fields. Brilliant plan. Except the toads ignored the beetles, became invasive themselves, and are now one of Australia's worst ecological nightmares. They eat native species, poison predators that try to eat them, and have spread across the continent like a plague. That was in 1935. And Australia is still dealing with the consequences almost 90 years later. Or how about the mongoose in Hawaii, brought in to control rats in sugar plantations? Seemed logical enough. Except, plot twist, rats are nocturnal and mongooses hunt during the day. So instead of solving the rat problem, they just created a mongoose problem. Now Hawaii has both rats and mongooses destroying native bird populations. Smooth move. The point is, biological control has a spotty track record at best, and apocalyptic consequences at worst. So why are scientists willing to roll the dice on this one? Because they've done their homework. Extensive homework. The research team spent years studying these lungworms. They tested them against dozens of native Florida snake species. Rattlesnakes, water snakes, garter snakes, you name it. And here's the crucial finding. The lungworms showed a strong preference for Burmese pythons. But the infection rates were significantly lower. It's like the parasites can tell the difference between an invasive giant and a native species. Not perfectly, but enough to make this worth considering. Plus, these lungworms have a narrow host range. They need snakes. They can't infect mammals, birds, or any other wildlife. So there's no risk of them jumping to humans, pets, or livestock. That's a huge deal when you're talking about releasing thousands of parasites into the wild. The last thing you want is for your snake solution to become a human problem. Now let's talk numbers, because the python invasion in Florida is staggering. Estimates suggest there are between 100,000 and 300,000 Burmese pythons slithering around the Everglades right now. That's a conservative estimate, by the way. Some researchers think the number could be even higher. And here's the thing. These snakes breed like crazy. A single female can lay up to 100 eggs at a time. Do the math on that reproductive rate, and you'll understand why every other control method has failed miserably. They've trained dogs to sniff out pythons. They've even deployed bounty hunters who get paid per snake. And while these efforts have removed thousands of pythons, it's barely made a dent. It's like trying to empty the ocean with a teaspoon. The snakes just keep multiplying faster than humans can catch them. In 2013, Florida held the Python Challenge, inviting hunters from across the country to bag as many pythons as possible. Over 1,600 people participated. Want to know how many pythons they caught? 68. That's it. In an entire month of intensive hunting across the Everglades, with prizes up to $1,500 per snake, they managed to remove 68 pythons. When you're dealing with a population in the hundreds of thousands, that's not even a rounding error. So yeah, desperate times call for desperate measures. Enter the lungworm program. The beauty of this approach is scalability. Once you release the parasites, they do the work for you. They spread naturally from python to python. They multiply on their own. You're not paying hunters by the hour or organizing massive search parties. You're letting nature handle nature, with a little human assistance, of course. But here's where it gets tricky. And I mean really tricky. Because ecosystems are complicated, interconnected webs of relationships that scientists still don't fully understand. When you introduce a new element, even a carefully studied one, you're essentially pulling a Jenga piece out of a tower and hoping the whole thing doesn't collapse. Let's game out some scenarios. Best case, the lungworms target pythons preferentially, spread through the population, reduce python numbers to manageable levels, and native wildlife starts to recover. The Everglades gradually return to something resembling their pre-invasion state. Raccoons make a comeback. Opossums rebound. The ecosystem stabilizes. Scientists get to write triumphant papers about successful biological control. Everyone's happy. Worst case, the lungworms mutate or adapt to infect native snake species more effectively. Florida's native snakes, already stressed from habitat loss and climate change, face a new deadly parasite. Populations crash. Predator-prey relationships collapse. Rodent populations explode without snakes to control them. Increased disease transmission, maybe even new invasive species, taking advantage of the chaos. The cure becomes worse than the disease. Middle case. And probably most likely, something complicated happens that nobody predicted. Maybe the lungworms work great on pythons, but they also infect just enough native snakes to cause localized problems. Or maybe pythons develop resistance faster than expected. Or maybe the parasites affect python behavior in unexpected ways that create new problems. Nature has a way of throwing curveballs that make even the best-laid plans look silly in hindsight. The research team is aware of these risks. They're not mad scientists cackling in a laboratory. They're serious ecologists who've spent decades studying invasive species and ecosystem dynamics. They've built mathematical models. They've run simulations. They've consulted with experts from around the world. And their conclusion is that the potential benefits outweigh the risks. But potential and guaranteed are two very different words. There's also the question of public perception. Because let's be honest, scientists release flesh-eating parasites into the wild is exactly the kind of headline that makes people nervous. It sounds like the opening scene of a disaster movie where everything goes horribly wrong and civilization collapses by the third act. Never mind that the parasites only affect snakes. Never mind the extensive research and safety protocols. People hear parasite release and immediately imagine worst-case scenarios. And you know what? That's not entirely unreasonable. Because history is full of examples where human intervention in nature went sideways. The difference is that modern science has better tools, better models, and better understanding than we did a century ago. But, perfect? Not even close. Here's what's actually happening on the ground. The lungworm release is being done in stages, small, controlled releases in specific areas, careful monitoring of both python and native snake populations, regular sampling to track infection rates, spread patterns, and any unexpected effects. This isn't a dump and hope situation. It's methodical, data-driven, and designed to be reversible if things go wrong. At least that's the plan. The monitoring is particularly important. Researchers are tracking individual pythons with radio transmitters, capturing and examining snakes regularly, and maintaining detailed records of infection rates and health indicators. They're also monitoring native snake populations in release areas compared to control areas without lungworms. If native snakes start showing problems, they can adjust or halt the program. But here's something most people don't realize. The python invasion isn't just an ecological problem, it's an economic one too. The Everglades are a major tourist destination. People visit from around the world to see alligators, wading birds, and the unique wetland ecosystem. Except now there's nothing to see. The wildlife has been decimated. Tour operators are struggling. Local businesses that depend on ecotourism are suffering. When the ecosystem collapses, local economies collapse with it. There's also the agricultural angle. Pythons don't stay in the Everglades. They're spreading north into agricultural areas, where they prey on chickens, rabbits, and other small livestock. Farmers are finding their animals disappearing, and there's not much they can do about it. A 15-foot python is not something you want showing up in your chicken coop at 2 a.m. And then there's the human safety factor. While Burmese pythons rarely attack humans, it has happened. Small children are at risk. Pets definitely are. There have been cases of pythons entering homes, hiding in garages, even showing up in swimming pools. It's not a common occurrence. But when you have hundreds of thousands of giant snakes roaming freely, the probability of negative human encounters goes up. So the lungworm program isn't just about saving the Everglades, though that's certainly the primary goal. It's about protecting an entire regional economy, safeguarding agricultural interests, and reducing human-wildlife conflict. The stakes are higher than most people realize. Now let's talk about the timeline, because this isn't going to be a quick fix. Even if the lungworms are wildly successful, it'll take years, possibly decades, to see significant python population reductions. Parasites don't work like poison. They spread slowly, build up over time, and gradually weaken the host population. This is a long game, not a quick solution. The program started with pilot releases in 2023. Initial results won't be fully analyzed until late 2025 at the earliest. And even then, those results will only tell us about short-term effects. The long-term ecological impact. That's something we won't understand for 10 or 20 years. Maybe longer. Which brings up an uncomfortable truth. The scientists behind this program are making decisions that will affect Florida's ecosystem for generations. They're doing it with the best available data and the most sophisticated models, but they're still making educated guesses about complex systems that nobody fully understands. It's like performing surgery on a patient you can only partially see, using instruments that might have unexpected effects, and hoping that your diagnosis was correct. But here's the thing, doing nothing isn't an option either. The python population is growing exponentially. The ecological damage is accelerating. Native species are disappearing at alarming rates. If we wait for perfect information, for absolute certainty, for zero risk, we'll wait forever. The Everglades as we know them will be gone. Permanently. This is the reality of conservation in the 21st century. We're dealing with problems of our own making. Invasive species, habitat destruction, climate change. And we have to find solutions using imperfect tools and incomplete information. It's messy, it's risky, and it's absolutely necessary. The lungworm program represents a calculated gamble. It's scientists looking at a catastrophic ecological crisis and saying, we think we can fix this, but there are risks, and here's how we're going to manage them. It's not perfect. It might not even work, but it might be the only realistic shot we have at saving the Everglades. And if it does work, If the lungworms successfully reduce python populations without devastating native snakes, this could become a model for managing other invasive species around the world. Because Florida isn't the only place dealing with ecological invasions. Brown tree snakes in Guam, lionfish in the Caribbean, wild pigs across the southern United States. The list goes on and on. We need better tools for managing these invasions, and biological control, done carefully and scientifically, might be one of those tools. So yeah, Florida is releasing thousands of creatures that kill snakes from the inside. It sounds insane. It is a bit insane, but it might also be brilliant. Time will tell. Thanks for watching, and if you want to see how this story develops, make sure you're subscribed because this is far from over.